think I successfully hit record. We'll find out when we watch the recording if the first things on the recording are me saying I think I successfully hit record. But anyway, thanks very much for being here, everyone. My name's Alan Rossman. I teach in the Department of Statistics at Cal Poly in beautiful San Luis Obispo, California. And several of my colleagues are here. Welcome to all of them. Welcome to everyone around the country and in other countries who are here. So let me introduce Beth. Beth Chance is a colleague of mine here at Cal Poly, and Beth and I have worked together on many things over the past going on 30 years. One of those things is the applet collection that Beth will be showing you some examples of. And I say we've collaborated on that, which is true to some extent, but Beth is by far the driving force behind the applets, their initial creation, their development, their maintenance. And so Beth has been working with these applets as well as lots of other projects related to teaching statistics for the past 25 years or so. This workshop is one of many that will be conducted from support from a recently awarded NSF grant that focuses on helping instructors to teach statistics according to the GAZE guidelines from the American Statistical Association. This particular workshop, as you know, is about using applets to have students explore statistical concepts. So at this point, I'll be quiet and thank Beth for being here and ask her to take over.
Thanks, Alan. And I did notice a few people in the chat were having audio issues, so maybe I can leave you to try and sort that out if you want. It does seem maybe just a setting they need to change. But I haven't heard from a non-Cal Poly person or a non-California person. They can hear okay? All right.
Sorry about that. Those of you that are having trouble, I'm not all that knowledgeable about Zoom, so I'm not the best one to help, but maybe others in the chat can help out or check your settings as was suggested. Lots of people can hear. Sorry about the ones who can't.
All right, so as Alan mentioned, what we wanted to focus on in this workshop was specifically these applets, but how we can use them to facilitate some of the GAZE guidelines, or just fostering active learning, helping students visualize key concepts, even multivariable thinking, and simulation-based inference, although that one we'll get more to in part 2 of the workshop. We're thinking this workshop is maybe just an initial introduction if you're not familiar with using applets or haven't been using them in your class. I do encourage you, we'll give you a link in a minute, and Alan sent out in the email to access the applets if you want to play along. And then if you have any specific questions as we go along, feel free to interrupt or put a question in the chat. A couple of people are helping monitor that so they can interrupt me if we needed to go over something specifically. And then if you have suggestions, or even after the workshop, if you have suggestions, these applets are still under development. We try never to take away functionality, but we're continually adding things to them. So if there's something you would like to see done differently, or just additional questions you have, feel free to contact us after the workshop as well. So for accessing the applets, you can go to this URL that Alan gave you previously. And that's actually kind of an older landing page. And then there's a newer landing page, which are called the updated applets, or any of these links now automatically take you to the updated applets. So the main way that you'll see that you're kind of on the newer page is it has the green banner across the top. And so again, there really shouldn't be any differences. Hopefully they're new and improved. There's a little bit more with some of the accessibility issues. So we've gone through that to try and make sure that, the color contrast and the screen reader and some of those capabilities are working a lot better. You can always just follow a link to an individual applet as well, or provide that link and go straight to it. And these should work on iPads. They work on students' phones. There's a lot of, screen space issues. They should work on Mac and PC, so that just as long as they have an internet connection. Or if you're in an environment where you want to do a demo in class and you don't have an internet connection, we can often send you a version that you can run locally as well. And one thing we did also add recently, so this header is also a link, just sends me back to that landing page, is we are starting to develop some videos to specific applets about how to use them. There's a place where you can report bugs in applets, and we can often respond to those very quickly. There's a little bit older guide to all the applets that we'll be updating soon that again gives some of the features that we'll be going over today. And then the applets that we're going to talk about today are mostly in the initial things you might be doing in a statistics class. So just looking at graphs of data, looking at regression lines, exploring probability. We'll talk probably about a couple of sampling distribution applets that we have, a little bit on traditional theory-based inference. But again, if you want to talk more or less about something, let us know as we go along. So the one I'm going to start with is that descriptive statistics applet. And this is a good time to talk about just different ways of getting data into the applets. So we tried to make the applets have a very consistent look and feel so that they all work very similarly and it doesn't feel very different to students, even though they're going into these different applets each time. But usually there's a text box where they can just type in data or paste in data. So how I usually use them is I might have data in like a spreadsheet and I can just select the columns that I want and then I can just copy from that spreadsheet. I can clear out what's in there and then I can paste and then I'll press use data to put it into the applet. A couple things to warn you about is I already changed the title of column D here. It used to be multiple words, and the applet doesn't do a good job at recognizing multiple words when you have multiple columns. So you need to use kind of one word variable names, or double check here that it doesn't say like winter space quarter or something, that your category names should also be one word as well. And then otherwise, it should work with either space delimited or tab delimited or comma delimited files. And then when you copy and paste, the applet will, if there's multiple columns, it'll pick the first one that it considers a quantitative variable and plot that. But then you have a pull down menu to go to a different variable if you want. And then the separate by is a list of the categorical variables that it saw, so those that had words. So you notice that year was only numbers, and so it automatically assumed it was a quantitative variable. So that's the kind of thing maybe to have students play around with, just to recognize which are being treated as quantitative variables and which are being treated as categorical variables. You can expand these windows to kind of get a better idea of what's going on here. And you'll notice that this was stacked data. When you first load in the applet, so I'm just going to reload it here and go back to descriptive statistics. It gives you a little bit of an idea of what that format might look like. So you should always include headers, but if you don't, you would take that off. So then it knows, again, it's just trying to recognize words versus variable names. And then stacked versus unstacked, this goes to just one variable, but if you had a data set that had multiple groups and multiple columns, then you would use the unstacked or not check that stacked button. And then there are some preloaded in data sets, not too many, and there's, to be honest, not a great place to find a description of these. They come from our textbooks, but we can, if you email us, we can give you more information. Some of these are a little explanatory. This is just a large data set of some data that was collected in a student project group a few years back about how heavy backpacks were, but you'll see there's lots of different variables that they can access in here. So when you do select a new variable, it kind of reminds you, you still need to, select a new data set. It reminds you that you need to press this button to kind of get it in and have that being the one that's used. Here's an example where if you do scroll down in this data set, I think you'll find an asterisk somewhere, over here. So the applet treats those as missing values, and it's just going to do row-wise deletion. It's just going to take out that whole row that had a missing value. So we don't have 100 people in this data set. We just have 99. So these little warnings pop up, and then you can just close them. They're just kind of messages, but sometimes you'll get an indication if the applet thinks there's an issue. And then sometimes you'll see down at the bottom, there's links to other specific data sets. But again, I think the most common way is kind of that copying and pasting. Just looking to see if there's anything else I was supposed to tell you about loading in data, or if anybody's having any issues on that. All right, so let's go to this Flint water just to have one variable here. All right, so a lot of that moves away, you don't have multiple variables to be selecting. You can also randomly generate a sample of data if you want, just to play around. So then in using this applet, one of the first things I like to do is just explore mean and median and have students think about how those relate to the graph of the data. And so we start them off with just kind of a movable line where they have to guess what they think the value of the mean is. And then once they think they have a reasonable guess, then they can compare that to the actual. And then they can move this line over to match that if they want. Or if they get rid of the guess, they still have a visual of where the applet was finding the mean, as well as reporting it over here. And then similarly for the median, I get a separate line that I could guess and try and figure out where I've divided that in half, how that's going to be related to the mean. And then again, I can compare that to the actual to see how I did. And similarly, we can do things like that with the standard deviation. Here, I'm going to select on these lines. So this is all just touch and play and move around with my mouse on where I think I found that, and I can compare it to the actual. So it's a little short there. And then the IQR, when you guess that, you get to move each of these separately. So the standard deviation, they were moving symmetrically. Here I can move them individually. And then when you do show the actual, it even shows you the calculation of how it was calculating, those two quartiles and then finding that. Right. And let me go back to guess for a minute here. Something that is a little bit newer in this applet to help students understand this mean as a balance point is I can show deviations from that value. And so they're kind of shown visually here. I have to go all the way out here to get to that point, whereas here I had a lot of smaller deviations. Those deviations in absolute value, or I'm sorry, just those deviations are getting graphed over here. And as you move that mean around, you can see that I need to kind of pull it out a little bit to balance those. So if you think of these as like weights on a balance beam, where's that fulcrum going to be to make those balance out? And so I had to pull to the right to balance out these really larger values. And that's a way to help them think about the mean in that distribution and how that's going to behave a little bit differently from the median. And so you can get the sum of the deviations. It's a little hard with rounding here, but you're thinking about getting that to be 0 essentially. So there's going to be rounding. I'm not going to be able to hit it exactly with this data set. And then you can also talk about the sum of the absolute deviations and then even go on to how that relates to the standard deviation if you want as well. And you can give them a visual of the squared deviations and again, how you're trying to kind of minimize that when you're finding the mean.
There's a question in the chat, Beth. What's being displayed in the shaded area?
The shaded area. What was?
Yeah, I'm not sure what shaded area is referring to. Do you want to elaborate on that?
In the question?
Maybe the red area, maybe?
Yeah, so these are just from that mean that you're still moving around at this point to each individual observation. So you're kind of getting, you can even think of them as residuals. They're just these deviations of each observation from that mean. And you can click on a dot and it gives you the row number. If you did have a data set where you had maybe an ID and you kind of told the applet that that was an ID variable, it would show you like a person's name or something like that here as well. One data set we have that works really well with is these times for the national anthems. And so I can graph how long it took different performers to sing the national anthem. If I try and go to a performer, I'm not going to really separate this by everybody because everybody had a distinct value. So the applet kind of recognizes that. But then when I click on an observation, it gives me not just the row number, but it gives me that person's name as well. And then we can see who the long ones were, as well as who the short one was. The only summary statistics that we give you in this applet is these 4. You can, yeah, I guess that's it as far as these 4. When you do work with the guesses, you can sometimes show some percentages. So like you can show how many are in that range, some information like that. So you can get some percentiles if you want, but that's about it for what this applet does. There are some other graphs you could do. Actually, another data set that's nice here is this Old Faithful data set. So notice here I put a Y in front of those numbers, so it would recognize it as a categorical variable rather than a quantitative variable. So that's something I might do in a spreadsheet first before I paste the data in. And I actually think it's kind of good for students to have to go back and forth between a spreadsheet and the applet, just to have more comfort level with the spreadsheet as well. So sometimes we do some pre-processing of the data before we put it into the applet. So I guess it wants stack data because I have 2 different years in here. And so this is an interesting data set because you can see some different clusterings in the data that you could get students to talk about. It's also where I'm starting to get a larger data set, so maybe a histogram would be more appropriate, but then I might want to think about how wide to make the bins of those histograms. And so I can play with that a little bit. Again, the main point is we're just trying to make it easy for students to play around and explore things and to ask some of the questions like you're asking, what does this mean? What is this showing me? What are some pros and cons of doing things different ways? You can also add a box plot. I don't think that needs to be an either or. I just overlay it right on the histogram so students can see those at the same time. And then you can toggle between modified and not modified box plots to, again, make it real easy for students to look at multiple representations very quickly. And then normal probability plot is something you could switch to as well. It's not the prettiest, but it gives them some information. And that might be most of it for this particular applet. Any questions you want to ask? For the random sampling, it does vary the sample size a little bit, and that's just random. We do keep them fairly small. It's mostly selecting from symmetric or right skewed or uniform distributions. And then I just like having students think about the relationship between the mean and median, depending on how that shows up. So just to, get to a point where maybe the mean is less than the median, what was true about that data set to make that happen, and see if they can start to discover those patterns. If I go back to a data set that did have a categorical variable like the times, then the separate by just allows you to pick something like genre. Maybe it says, gee, that's a lot of groups. Maybe I should go to genre 2 that's already in here that has a smaller number of groups. It does start to get a little crowded, but again, you can expand this out a little bit if you want more or less detail there.
There was a question about stacked versus unstacked. Can you explain that again, please?
Well, because I'm realizing that this doesn't do, it used to give you, so if I just reload this, this is stacked, and then when you go to unstacked, it used to give you that version of that same data set where the response variables in different columns for different groups, rather than what's more traditional now is to have one group be all the category, one column be all the categories, and one column be the quantitative variable. So I actually don't play with this too much anymore. I'm pretty much always giving them where each column is a variable now. But they may come across data that's in a unstacked format, and when they go to paste that in, they just need to tell the applet how to read that in as multiple groups rather than multiple variables.
Another question in the chat, can students click the plot and add their own points?
Not really. They would do that here where maybe I want to add another one here, and then I would just press use data, and then I can add one there. So you can say things like, how big do I have to make this value to, make maybe the mean a certain value. The other thing you can do is you can take a value like this and just move it along, and it rescales automatically. And so you can see how the mean's changing, but the median's not, as you move that along the axis here, maybe more slowly. And so you can get at some of those. When you do have a highlighted one as well, you can then delete it and that snaps back. Or if you want to put it back in, just go to revert and it goes back to the data set that you had pressed use data on to go back and forth there. The sample size of 202 was just in the data set here. This was just data we'd pre-collected. So stacked. It just happened to be the data set we had for that particular context. All right. So many of these same ideas will come up in the next applet. So I'm going to go to it's called the two-way tables applet, or if I go to the dolphin study applet, that one does have data preloaded in, and it has some column names and some row names. These are grayed out, but you can edit these if you want, and you can put in your own data. This is where you might want to go to a generic 2x2 table, and it'll go to this format where this box is checked, where you can enter your own table, and so you can enter your own column names and your own row names. This goes up to a 3x3 table if you want to do more than that. Or if you uncheck that box, you're back to this format where you can paste in data, or there is a few preloaded in data sets like this dolphin data set, but now in this format where each column is a variable. So this is whether they were in a dolphin group or a control group, and then a response whether they improved or not. So again, there's not a lot of information about some of these data sets. And so if you just want to type in your own data, this might be the easiest way to do it. And so it'll update the totals as you go along. You can even do things like 20 minus 15 if you know just the successes and the totals. And then when you press use table, because now it's in the table format rather than the raw data format, it'll do that one calculation for you. And then you can do a segmented bar graph. You can see the observed difference in the proportions. You can change this to what's called a mosaic plot. The only difference there is the width of the bars will vary depending on the relative sample size between those two groups. You want to subtract in the other order. You want to switch which one is kind of being success or failure, and that'll change the difference that you're subtracting down here. And then you do have access to a few other statistics like relative risk and odds ratio. And those again get calculated for students here. And that's the kind of thing where I might just have students calculate it yourself and then go to the applet to check their answer. So again, here, just what you might do if you had all categorical data. This might be a little bit of a faster introduction to some different graphs for you there. And I think that's all we really wanted to show you for as far as descriptive statistics in that applet. Most of the applets now do have a Spanish version that I've gotten some help with the translation, and so everything should look the same. And then just most of that stuff will be translated in Spanish as well. And then maybe I need to choose a few more words. So if you have some questions with that, just let us know. Or things that you think can be done better. Yeah, some of the formatting might not work out as well, but we can keep playing with that. So I don't test out the Spanish version as much, so definitely let us know if you find some issues. So back to the main applet landing page, there's a link for two-way tables, or if you want specific data loaded in, there's a dolphin study version that you can go straight to as well. And then as far as, again, descriptive statistics, the other one that I wanted to talk about was least squares regression. And this is going to assume two quantitative variables. Again, you can paste in your own data. You can paste in more columns if you want, including both quantitative and categorical. Or there's a few pre-selected ones. Once you have more than two variables, then you need to tell it which one you want to be the response variable and which one you want to be the explanatory variable. You can also color code by some variables that you have or not, and then you can show specific descriptive statistics of just those. One thing I'm going to do in this app, well, I'll get to that, I think. Let me actually get rid of the color coding now. But we like this, color coding, again, very quick and easy, just getting students to think about multiple variables and make it easy for them to look at lots of different graphs. So it would be really easy for them to see which is a better predictor of height, foot length or hand span, and they can just toggle back and forth between those variables pretty quickly. And then this show movable line just gives them a line that actually starts at the Y bar value. And then it gives them a square in the middle that if they click on that with their mouse or on their touchpad, they can move that up and down. And then it gives them these squares on the end, whereas if you can click on those, it allows them to change the slope. So I use this to have students think about, well, what line do you think is doing the best job of kind of summarizing this association in here? And well, what do I mean by best job? So I can show residuals and I can show the sum of the absolute errors. And then they can keep moving this around and see, well, what minimizes those absolute errors or what minimizes the squared errors, because that might actually be a little bit different. So this is the sum of the squared errors. And so again, I can tweak a little bit. We make this a little contest in class to see who can get the smallest value for the sum of the squared errors. And then we can say, well, there really is one right answer here, one line that does minimize the sum of the squared errors, and that's the regression line. And so hopefully this gives them a sense of why that least squares regression line is the best fit line, or what it means to be the best fit line, and how that's in terms of the squared residuals, not just the residuals themselves. And so that's how I introduce this least squares regression line for them. And there's not great format here, but I do try and always get them thinking about how this is the predicted height and then interpreting this equation. And then they can get very traditional output like the correlation coefficient, the R-squared value, now with a little pie chart to help them think about, how much of that overall variability is being explained by the model and how much is still being unexplained. And then the regression standard error as well, just to get them thinking about that as kind of the standard deviation of those residuals roughly pretty quickly. And then again, you can click on a value and then you can delete that and then instantly see how that changes all of those statistics. And then you can put it back in, back to that original equation as well. There's more data options here. It is a little bit easier to maybe add an individual observation to the data set and see what impact that has. Again, you can also click on an observation, and if you check this box to say move observations, that then gives you the ability to move this up and down and right and left. So that's why we don't want it too easy. But then, yeah, where can I put this point, or how can I move it around to even get a negative slope? Right? Is it more or less sensitive, the line more or less sensitive to moving points in the middle of the graph versus moving points that were way out here with the extreme X values? So you can talk about issues of resistance, things like that. And again, you can go back to the original data set as well. And then I think there was a question about kind of traditional computer output. So you can get some very traditional computer output, like for the regression table or for the ANOVA table. And again, this is all tied together. So if they start doing things, then all of that's going to update right away as well. Anything else I'm missing to show here? Yeah, we thought about changing this to predicted height, and some of it's just kind of a spacing issue as well. And we think this out here versus on top of it is one issue. Some of the applets will show you do have a little bit more ability if you want certain notation or certain kind of language and formatting, you can do that. So there's a little bit of instructor leeway, but not a ton. And then, yeah, this just switches which one's on the vertical axis, which one's on the horizontal axis. Everything updates from that. So yeah, when you do start with the movable line, this is at that initial, now I've changed the variables, but the initial y bar value. So you can take this sum of squared errors and you can divide it by n-1 and you can take the square root and you're just back to the original standard deviation of the response variable. In fact, we are working on a variation of this applet where instead of using these weird acronyms, we just report the standard deviation of the residuals. And so then they can really be thinking about how this is related to that relationship between the variability about the regression line and that overall variability, and how R squared is kind of that fraction of the variability you've been explaining. Change variable selection. I think you need to be in a data set, and because I was playing around with revert and everything that has multiple variables, more than two, for you to see that change variable selections output. So if there's only two variables here, it's not going to give you that. So if I just go back to foot height, it doesn't give me that. It just gives me that ability to switch which one's the response variable and which one's the explanatory variable in that setup. And another thing I meant to show, but I don't know if I can, here is when you do move this around, you'll see that updating over here as well. So again, you can always type values in here and create really strange observations directly that way as well.
Give the two variables applet before Beth moves on in a slightly different direction. I guess it's time to move on.
All right, let me just double check if there was anything else. Nope, that I wanted to be sure to say. So moving on, we're going to talk about a couple applets that focus on introducing students to the idea of just randomness and what we mean by saying the probability of something happening. And I think students nowadays are pretty comfortable with what's going on here. We do like maybe I shouldn't try and go too off script here. But when we get to randomness, I think it's important to give students very concrete examples even before you get to the applets, just to help them better understand what the applet's doing, and it doesn't just seem like a black box and magic. And so one of the examples we sometimes use is called random babies. And so when I say give them something concrete, we have them do a tactile simulation first of a random process. And so Alan gets credit for coming up with this absurd context where we're going to have four mothers give birth to four baby boys the same night in a hospital, but the boys are going to get returned to their mothers at random. And so we have them say, here's the four mothers, and then they're writing these boy names on index cards that then get shuffled up and dealt back to the mothers. And then we have them count how many mothers got the right baby. And then we think about, well, how often is it zero mothers? How often is it all four mothers? How often is it 3 out of 4 mothers? So it's just this interesting context, but we want them to explore randomness. And so we do have them do it with index cards, and in class first, they share their results at the front of the room on the whiteboard before we even get to the applet. Just again, so the applet's not as much of a black box, and they kind of believe the applet a little bit more. We don't think this is as necessary with the descriptive statistics, with the graphs and the summary statistics. You know, they believe that. We just want it to not be too easy for them to kind of manipulate the data themselves. But with randomness, we do a tactile simulation first. And then we go to an applet called random babies. And another thing we've tried to do with the applets is make them represent that tactile simulation as closely as possible. And so you're going to see a simulation of randomly assigning babies, and we make them sign a waiver that, you know, they're going to learn where babies are coming from. So here are the babies getting to the hospital and then being returned to their mothers. And then these were all rain clouds because none of the mothers got their own baby. And so you may have noticed that by the color of the diaper was not matching the color of the house. I can see it's going to be one of those days where I'm just not getting a lot of good luck here. There's one. All right, so that was one match. And so this data has been accumulating over here. We had several zero matches. We had one with one match. And so maybe even take off the randomized to do this more quickly, right? And just to start to see that variability. And then we can start to do a larger number of trials at once. And so you can see that the histogram is updating and this graph down here is updating as well. And so what I really want students thinking about is how this graph is converging to one number. And so what is this a graph of? Right now it's a graph of the average matches. So here's all the matches. Here's how often we got those matches. And we want students to think about why we never get 3 matches, but we do sometimes get all 4 moms getting the right baby, but most of the time only 0 or 1 mom is getting the right baby. And so we're looking at that average and we're seeing how that average is changing as we do more and more repetitions of this random process. Or we could focus on, the proportion of times that I'm clicking on this one bar here. And so I've changed this to relative frequency. So it's the relative frequency of one match. So the proportion of times that one mom got the right baby. So kind of looking at this number here and seeing how that's changing and how it's not changing so much anymore. Now that I'm up into over 100, 200 trials, it's not changing very much. And so this is converging to one number. And that one number is how we're going to want them to think about probability in this course. So we want them to think about probabilities. If you could repeat this identical random process multiple times, it's going to converge to that one number. And so I'm going to check show theoretical here, and it's going to converge to 1/3. And then we come back and maybe show mathematically why it's 1/3. I don't think that's totally obvious, all right? But more, I want them to think about how I want them to interpret probability as this long run relative frequency, and even how I want them to interpret expected value as this long run average. And again, it's going to bounce around a lot in the beginning, but then get closer and closer to that right answer if I was able to do this, hundreds and thousands of times. And so again, hopefully they can explore this pretty quickly and then start to see that convergence, but it could be, 500 or 1,000 before I'm getting really close to that theoretical value. All right. And then another one that I sometimes do here with the same goal is the Monty Hall problem. And again, I'll just kind of start doing this pretty quickly. Well, they play the game, but again, I would maybe do it with index cards or something first, where one person's the host and another person's kind of making their guess. So I picked door number 1. The host says, well, I'm going to show you that there's a bad prize behind door number 3, and I'm going to give you that over to the other door. And then we ask students to decide if one of those strategies is better than another. And students often aren't familiar with this. Here I chose door 1 again, and I won the car rather than the other goat. And so we have them, try each strategy out for a while. We take off animation. And they start to see, again, that bouncing around behavior going to some limit. And then now if I try the switch strategy, again, it's going to bounce around for a while, and there may not be a difference between the strategies. But eventually, if I was to play this long enough, that switching strategy does end up being superior to that staying strategy. But again, I just want them to have this visual, right, of what it means to repeat this event many times. And then that's what we're going to mean by probability in this particular course. And then we do have some probability calculators here. So I don't ever have my students look at even a normal probability up in the back of the book anymore. One thing we do is make them, come up with a variable and make sure that that's going to be on the graph, and then maybe put in some values, and then scale to fit is what draws them a picture and then forces them to think about that variable in the graph. But then you also have these z values down here as well. So if I want to calculate, say, the probability of being above 110, I just turn that one on, and then I'm just hitting return to kind of enter these values. And you can also move this line and you can see how that's changing, how that's getting the z-value, how that's changing the probability. You can type in a probability and it'll give you the z-value and the x-value that go with it for that mean and standard deviation, or you can type in a z-value and it'll give you the x-value and the probability. And then you can compare that to another distribution that maybe has a different mean. Scale to fit won't change for the green distribution, so maybe I'll give it a better standard deviation here, but they can kind of compare and contrast. So this just gives you the visual for the second distribution. But then if you use this box down here, it allows you to find probabilities, between numbers and things like that as well. And so they can play around and say, well, what's going to give me the middle 95% or something like that. And then the scale to fit, the z-values are always down here at the bottom as well. So I just give them this instead of looking at a table, so they always have to be thinking about the picture that goes with these probabilities as well. And so again, this would maybe be a little bit later in the course, and then I'm saying, okay, now how do you interpret that as well? 2.5% of the time, and then thinking about of IQs are going to be in that particular region, things like that. All right.
Any
So
questions
that's,
on these probability applets before Beth moves on to slightly new direction again?
yeah.
It's time for the next topic.
All right. So then it's going to be generally sampling distributions, but again, we like students to do something kind of concrete first. And so I give them this passage, which is the Gettysburg Address, and I ask them to just circle. I might give them a hard copy or to just somehow highlight 10 of these words. And I do try and get them to do this quickly. I may say, representative words, but they don't really know what I mean by that yet. And so then they'll just circle 10 words, and then I'll ask them to figure out what the length of the words was, so just the number of letters in the words, and then they'll find the average of that, and then they'll construct a plot on the front of on the board in the front of the room of those averages that each person got. So then each of these dots is an average of 10 words. And so they do that part first. So this is a copy from Ellen's class recently. And then I'll come along and say, well, I actually spent the time one day and figured out the lengths of all 268 words, and I found the real population mean, and that was around 4.3. And then students have a nice visual of sampling bias because very few people in the class underestimated the population mean. Almost everybody overestimated the population mean. And then they can start to think about why that makes sense. Those words are longer, those words are more meaningful. It's easy to miss the ofs and the a's that maybe aren't that interesting in the passage. And so we talk about, well, what would be a better way to get 10 words from the Gettysburg Address? And so we actually do that, where they'll take a random sample. I'll give them a sampling frame where every word is numbered. We'll use a random number generator, probably on the computer rather than a table, but we'll get 10 ID numbers. We'll go back, we'll get the words, we'll find the lengths of those words, and then we'll create another dot plot that is going to now be centered around 4.3 instead of this systematic tendency to overestimate. And then we'll want to play around with that. Well, what happens if I change the sample size or different ways of sampling? And that's when I think it's time to turn it over to the technology to be able to do that much more quickly. So we'll again explore this idea of randomness before we get to the technology. But then again, we have an applet that tries to match that as directly as possible so students have a better feel or belief in what's going on in the applet. And so here, this preloads in this Gettysburg address. There's several variables, but they can see those same words. They can see the lengths. And then I've chosen the lengths to be the variable that I'm graphing here. And so there's that 4.3, and there's that population size that we talked about. And so now if I go to show sampling options, one of the things I can do is take a random sample of 10 words. And then here's the lengths of those 10 words, and then here's that sample mean. And then people will still see that everybody got a different random sample. We get a different mean here, or they can do that themselves. Just keep taking different samples. We'll see what changes here, and hopefully maybe a little visual. These are just coming from that same population, but I'm getting some sample to sample variability. And hopefully I can do enough of these, I might start to see a pattern here. And so let me start going 10 at a time. We like having kind of the individual blocks here. You can also click on one of these to see the sample that created it, to keep that connection so it's not so abstract for them. But then we finally start to build up a distribution, and then they'll kind of morph into a histogram a little bit more. And then that's a question you can ask them. Have I run this simulation long enough? Have I done enough repetitions that I think I'm getting to that long run pattern? And so, hopefully by 1,000 or so, they might be convinced that I have a pretty good idea of what this distribution is going to look like, that is going to be centered around that population mean. And then you can start talking a lot about the standard deviation of that population. And then we've tried to make it so you can choose some other statistics like the median, and they might not know exactly what that's going to look like. You can do a standard deviation of, a sampling distribution of the standard deviations. You can do percentiles, or eventually get to t-statistics. You can scale this so that it's on the same scale. Let me go back to the mean, sorry, as the population, 0 to 12, and they can get a visual of just how much less variability there is. Or you can say kind of stay here, and now when I do something like increase the sample size, I get that same scaling and I get that much skinnier distribution. Or if I want to better see that distribution, then again, I rescale it. So we want them to play with different sample sizes. You can also play with different population sizes. So if I just put 100 copies of the Gettysburg Address here, that's not going to change this picture much other than the population size. And then you can have them compare that to this distribution. And if they look carefully, this distribution hasn't changed very much either. And so I'm trying to convince them that the population size doesn't matter, that only that sample size that they're changing here matters. One warning I'll give you is it takes them a while to get used to the difference between number of samples and sample size and thinking about what those are telling you. But I would ask lots of follow-up questions about that. But yeah, just this idea of a sampling distribution and how it relates to the population, but maybe in a little bit more concrete context, and maybe where they've had a chance to play with that population first. Another one that we use a fair bit is Reese's Pieces, because we get to hand out bags of Reese's Pieces to students. And we're just having them count. So, or give them, if you want to switch to M&Ms for peanut allergies or whatever. But again, just trying to have them have that tactile experience where they're all going to get their own proportion. They're going to make a dot plot, like crowdsource that dot plot at the front of the room before we turn it over to the applet, and then have the applet mimic that as much as possible by showing them taking the sample of 25 candies from that same population, and then everybody gets their own little dot, and then we can keep repeating that, start to see that distribution, finally go up to a large number. And again, now it's hard to see the individual dots, so maybe do that process a little bit more slowly, but then I can start to look at things like what's the mean of the distribution, what's the standard deviation of that distribution, how does the distribution change if I switch my statistic from the number of orange in this case to the proportion of orange, and then you can overlay a normal distribution just to see if it's having that same behavior. You can compare it to an exact binomial distribution. I might mention that just to let them know that there is an exact distribution, right? But notice that even 1,000 random samples gives me a pretty good match to that exact distribution. And just to, again, have them have that kind of terminology or that comfort level with some of these different distributions. All right. And let me go back to the sampling words. Somebody said they were trying to change to Beyonce, and then they need to press use data. I think what might be happening is this might be a good time to point out is how we do some of these things is we pass the applet certain kind of parameters. So I'm going to take that off and go to the more generic version of this applet, and I'm going to cross my fingers that it's not working. So that's an applet bug that we can play. Yeah, no, this is right. So this is the lyrics to a Beyonce song. I can't tell you which one, but it's doing some of the same information like length and whether or not it has the letter E. So if you want to switch to a categorical variable, you have that option if it's in those populations here. All right, and so then you can switch to different populations to sample from. So if you think a Beyonce song would be more interesting to your students than the Gettysburg Address, that's an option as well. The only time you might have to click use data twice is another way of entering data I haven't shown you, where if the data set is living in this Rossman chance directory, you can type the name of the data set in here, and then you press use data once to load it in here, and then you press use data two. But that's kind of an advanced maneuver. This is another population where it's supposed to be hours of sleep, where we force it to have a mean of 8 and a standard deviation 1.5, but then we want students to be able to explore different population shapes. And so they can look at skew to the right, they could look at uniform, and they can see how that impacts the sampling distribution in addition to sample size and population size. So you shouldn't have to do use data. So if that's not working for, or more than once, so that may be something we can talk about individually if you want. Was that you, Alan? I didn't hear you.
Any, why don't we move on to the last applet, and then we'll probably have a minute or two for questions at the end.
And that was the theory-based inference applet.
Right.
So this is just kind of traditional 1 and 2 group settings. So you could do 1 proportion, 1 mean, 2 proportion, 2 means. And depending on what you select, you have a few different options. Again, you can paste in your own data, and you have to worry about whether there's a header or not and press use data, or you can just give it summary statistics. One thing I like here is it'll compute the sample proportion for me, or vice versa. If I want to force a certain sample proportion and a sample size, it finds the count. But then calculate just gives you a graph. And then you can do fairly traditional tests of significance, where you get to specify the hypothesized value. It'll force it to be the same for both the null and the alternative. And then you just press this button to toggle between greater than, less than, or not equal to for two-sided. And so all of this was updating automatically, and you get what we call a standardized statistic, but also tells you the label of the z-score and the p-value. And so you can see how that changes as you're toggling things. And then the confidence interval, you can change that. And then pressing calculate CI will immediately update that, and you can do one of these if you want to go straight to the confidence interval. You don't have to do the test of significance. And then with 2 means, I feel like there was, again, whether the data stacked or not, this maybe give you a little bit here where there are 2 different groups if I include a header. So if this is again what we meant by unstacked data, all the males are in one column, all the females are another column. Or stack data, you have group 1, group 2, and then the quantitative variable of their weights. So if I press use data, then that'll show me the summary statistics and give me a graph. Not as nice as some of the other graphs, so sometimes I use these in combination. But again, I can do a confidence interval, or I could do a test of significance, and this all works the same way. So again, we think that consistent look and feel is kind of important. And then the only thing I didn't really highlight today and I'm not finding a good example of it. Here's one. We're trying to get more and more of these where if you mouse over the button, it gives this little tooltip that gives you a little bit more information of what's going on. And then there's a few other applets where if you do something kind of incorrect, that's going to mess up the applet. It tries to give you an error message and says, you know, don't put a negative value for a standard deviation or something like that. Paired data is its own applet, or if you're using the one mean applet and you just give it the differences already, you could just do that here and just do a paired t-test that way. And I'll go back to one proportion. We use pi to represent the population proportion. I know that's not everybody's favorite, so there's a link down here to change it to p. So when I go to this output, it's in terms of p instead of in terms of pi. So sometimes there's little options like that, or little, you know, things we can put in there for you if you'd like. Just let us know. And then I did have one more slide that I'll end on here of just some things I do in class. So just, you can embed these applets into other web pages with like kind of iframes. And so here's some instructions and they can scroll through these instructions and the applet stays right here with them. And this was just to remind me, and we'll talk more about simulation models next time, but I think this idea of a model is students need a little bit more repetition of what that means, or just reinforcement from what I used to think. And so this is, I might do this as a lab where they're just kind of doing this in class and I'm giving them instructions. They just do screen captures to show me their output, and then we kind of go on from there. And so each week they're probably seeing a new applet, but again, hopefully with enough consistent look and feel that it doesn't feel that different to them. So our commitments are to keep these free, make them easy for students to ask what if questions, to be able to do some exploration on their own, to be visual and engaging. And so there may be suggestions you have for improving that, but also reinforcing good habits like that axis labeling, the normal probability plot. And again, make sure they're always looking at graphs along at the same time. But I think one big advantage of the applets over some other things that they are much more dynamic and interactive as far as moving things around and resizing things. But I do think it's important to make sure students start slowly with the applets to really understand what they're doing, that they don't become just a black box. You're not just jumping to that traditional output, and to try and build them up in their complexity and to use them on assessment as well. And I'm seeing lots of signing off. So just a reminder that our next workshop will be next week at the same time, and we can talk more about these, or talk about hopefully the simulation-based inference applets and some more multivariable applets then as well.
Week, like Beth just said, will be about simulation-based inference and multivariable thinking. Even if those terms don't mean anything to you, you're very welcome to attend. Beth will be explaining what those terms mean and how she has students learn about those things. Let me also encourage you to jot down Beth's email address. One of the amazing things about Beth is she's incredible at responding to people very quickly, and she's very sincere when she says she wants feedback and suggestions on the applets. So please take her up on that. I will send out an email message with a link to the recording at some point, maybe later today, maybe not until over the weekend, or worst case on Monday morning, but I will be sharing the link to the recording with you. Please do come back next week, like Beth said, and I'll give Beth the final word.
No, I was just going to say save the chat, so I think you'll have access
Yeah.
to it, and I won't, and I'll go back to the Beyonce question on that.
Yeah. Okay. Thank you, everyone. Have a good day. Have a good weekend. Hope to see you next Friday.
Thank you, everyone.
I'll wait another few seconds to save the chat in case anyone wants to chat. Save chat. So if you want to save the chat too, it couldn't hurt to have some redundancy.
Okay.
Thanks.
I was going to wait for everyone to log off, or maybe we can meet it briefly afterwards because I had a couple comments to share, but more just for the four of us, or well, for Beth, Alan, Soma.
Is Andy still here? Because something I did forget to say is
Yeah.
these are JavaScript, and the original URL gives these Java ones, and these are the ones that don't work anymore, but everything on here should now work.
Go ahead, Andrew. It seems like the others may not be actively participating at the moment.
Well, I just wanted to comment that in the spirit of some of the discussions we've had about sharing more curricular materials, I was a little disappointed that some of the advocates for that, well, most of the advocates for that were not in attendance to